Now what we can do here is, okay, we'll just leave this system right here. We'll come back to this system later and we'll call this a b double dash, right? Now consider what happened in the historical times when there were, kings and battles and everything. Now before a battle, a king had to, there were a lot of principles at that time, so you just don't go inside palaces and start hitting people. There were notices that were sent, there were messages that were sent to other people, other kings, that you can surrender, or you can do this, or we're gonna battle with you on this date, and so on. So so let's say there's a king A, or let's just call it K. So this king K, and there's another king J. Okay, these are two different kingdoms, and this king wants to attack and capture the kingdom of King J. So what he does is he sends a messenger with a message. They were like something like this. You could read the message, and it used to open like this. There were no notebooks at that time, right? So he used to walk through villages and all the rest of the kingdoms in between K and J, and then he used to deliver the message to J. And another principle was that you never kill a messenger, right? So if this guy is a messenger, J gets angry reading the message or anything, but he cannot harm the messenger, right? So while traveling through all these villages, and this took a pretty long time, right? Now this is pretty much analogous to the system A B double dash, right? This is what is essentially happening over there. Now another method was, this was also used by kings. They established little towers or tombs, whatever you call them, in between all the possible regions and kingdoms, right? So there were towers between K's kingdom and J's kingdom. And let's say K has another region, so they would establish all these little buildings sort of stuffs, and they were round, so they look like tombs in between the two regions. And there was one guy on each tomb, right? So one guy on each. And this is what happened when there was a message to be sent from one region to another region. Let's say this is the message. The king shouted out the message, or basically not the king, but a messenger shouted out the message from the kingdom. And this message could travel, these were at small distances, so it could travel to the next tomb, and then this would go on until it reached the other kingdom, and you could get the message. But again, there was a problem. The problem was that some noise could enter between the two tombs and the message could be deteriorated. Now this is analogous to putting boosters midway and in between intervals in the system A B double dash. Let's say this was A, this was B. There was your transducers, and now you can put a booster here, you can put a booster here, you can put a booster here. Let's say this booster is midway, so everything that comes up till the midway, any noise, any signal is amplified or boosted by this booster. Now, this booster is definitely just an amplifier. Okay, and an amplifier is basically, if you have an input signal, it amplifies the input signal, and the output signal has a higher amplitude. It is amplified, and since there's no free lunch, there's an external voltage source that is used to provide the extra energy that comes. And since communication is just a higher level abstraction of electronics, and it's like an application of electronics, we're not going to get into the electronic devices as such. There are a lot of courses available for that, right? So but the problem was that all the noise that entered halfway was also amplified by this booster. So what we did was we established, we added two more boosters, 3/4 ways, sorry, 1/4, or how we divide this, right? Another here, and then we could do this repeatedly until there are infinite boosters between A and B, so that the signal that comes from A is amplified at each point between A and B. And when it is amplified at each point, it will be the same signal that reaches B. However, this is definitely impractical. You cannot add infinite just infinite boosters between any 2 points, right? It's not possible and it's not practical. It's not even possible, right? So this is analogous to what the kings did in their times. So now there had to be some other way of transmitting the signal. So what they did was they started using horses. Okay. Again, there's this king K and J. Okay, I don't know why they didn't do this earlier, but they gave him a horse, and then he could travel through the villages at great speeds with the message, deliver the message, come back on the horse, right? Okay, forget about coming back. So the horse is basically like a high frequency wave. Since the guy actually walks very slow and the horse is very fast, so we're using the horse to deliver the message, right? So we're just using a high frequency wave. What we're doing is we're imposing the, not superimposing exactly, we're using the guy to sit on the horse, and just it's like a wave, a message signal that has low frequency sits on a message signal that has high frequency, and then the guy gets off the horse and the message is delivered. So this is called modulation, and the getting of the horse thing is known as demodulation. Of course, this is a very high frequency, right? This is demodulation. So apart from the transducers that existed in A, B dash dash system, we have further two additions to the system. That is the modulator and the demodulator. Okay, and then the output transducer, and then the destination. So the source, the destination. Your source is A and your destination is still B. Now everything between modulation is demodulation is the channel, and all the possible noises that can enter is right here in the channel, from different noise sources, right? So it will add to the modulated signal now, and not to the signal that comes from the input transistor, because we now have the modulator. And the device that performs modulation is known as transmitter as a whole, and demodulation is performed at the receiver. Okay, so again, this signal is low frequency, this is a high frequency signal, this is again a high frequency signal with lots of noise, and there you remove noise and take out the low frequency signal to the output. So this is a general communication system that you can study theoretically, and as engineers, your basic task is to reduce the amount of noise that can come into the channel, and your basic aim is to receive the same signal that was transmitted. Okay, so the signal that is received should be an exact replica of the signal that is transmitted. That is what you have to do pretty much. Now So there's another thing you can see here is that how do we modulate and demodulate? When you're modulating, you're basically using, let's say we have this high frequency wave, okay, and we have this message signal. We're still not looking at stuff mathematically, but that's what you actually do in communication, and that's what you're going to do for the rest of the tutorials. But we, as an introduction, you can just look at it theoretically to just get to get the basic concept of communication. So what you do is you modify some property of the carrier signal using some property of the message signal. The horse is the carrier, right? And at the receiver's end, you do the exact opposite. You take out the property that you modified of the carrier signal, and what you obtain then is the message signal. Alright, some property of the carrier signal. Now there are three properties in any sinusoidal waveform. Any sinusoidal waveform, as you know, could be represented as a cos or sine omega t plus phi, let's say phi, right? So there's amplitude, there's frequency, and there's phase. So this leads to three kinds of modulation techniques: amplitude modulation, AM, frequency modulation, FM, and phase modulation, PM. Again, you modify a property of the carrier and not the message signal. You modify a property of the carrier, let's say you modify the amplitude, you include the amplitude of the message signal, but you keep the frequency and the phase of the carrier signal. Or you can include the frequency of the message signal but keep the amplitude and phase of the carrier signal. So this is how it works, right? And again, at the receiver's end, you extract that property and you get the message signal.